So important model that we use for multiplication is going to be the area model. So we're just going to revisit this again. So without a calculator, if I want to multiply 23 times 12, I may know my 23 multiples or my 12 multiples and be able to do it that way. But otherwise, I may want to break this down and decompose the multiplication. And we can do this very easily in our box method or area model multiplication. So I do 10 times 20, so I annex the zeros and times 1 and 2. 3 times 10, 30. Okay, 4 times 20 is 40. 6, so I know this is going to be 276. Okay, when I add that all up, because I know that the area of 20 and 12 is going to give me that area, so I can do it in pieces or I can do it all at once. It doesn't matter, we get the same result. So here 31 times 24, so I can decompose this into 30 plus 1. Typically we break it into tens and ones because it tends to be easier, but we can break it any way we want because the length's going to be conserved. That means the area is going to be conserved. So here I'm going to end up with 600. 4 groups of 30 is 120. 1 group of 20 is 20. And 4 times 1 is 4. So summing that all up, I get 744 is my total. Here, I can, if I have 3 times 12, I can distribute like this. I can do 3 times 10 is 30. 3 times 6, so 3 times 2 is 6. And I get 30 plus 6, which is 36. Now, I don't really need to do this because I know my times by 12 facts, and I know that 3 times 12 really is 36. But this is something I can do. I can decompose my multiplication across addition, subtraction. This is okay because it's multiplication with addition. Now, if it was powers with addition, this can't be done. But since it's multiplication and addition, we know that they are compatible with each other. And we will just distribute across and we can do this distribution. Now, what if we don't know one part of this bracket? We don't know the length here. So how do we work this out? Okay, because before here, I could just add 10 plus 2 is 12 times 3. Here, a plus 2, I cannot add those together. A plus 2 is a plus 2. We cannot count a's with ones. So how do I sum this all up? Well, I can think of it this way. Multiplication is, here I have a times 3. Well, 3 groups of a is just 3a. I mean, I could think of it this way as well. I can think of it as 3 layers of a. I have a, so I have 3 separate a's. Okay, well, that would mean I have 3 a's. Now, ideally, hopefully we don't need to draw in every part, and we can just say that 3 times a is 3a. And 3 times 2, again, we don't need to draw in the 3 layers of 2, right? We know that's 6. We can just say that is an area of 6. And so what we can do is we can distribute this out just like we did before. We can actually distribute the multiplication because we know that we're decomposing into parts. And I can do this part here, the a part, separately from the 2 part, and then combine it together afterwards. So I end up with 3a plus 6. The difference here, though, is we don't now combine this because these are not like terms. I cannot count a's and ones the same, so I just keep them separate like that, and that's good enough. But we can deal with these brackets and these algebraic terms by getting rid of them by distributing that multiplication. So this works the same with algebra tiles. If I have algebra tiles, really, I want to distribute that out. Okay, so I have 2 groups of 3x. Well, if I take a look at this, it said 3x along the horizontal, 3x plus 1, that's my edge length. If I multiply this together, 3 groups of 3x is going to give me 1 group of 3x here, another group of 3x here, so I have a total of 6x. And if I distribute 2 times 3x, yeah, that's definitely 6x. Because although they're separated, 3x plus 2, we can look at them distinctly. They still share the same edge length of 2. And so now we have 2 groups of 1, or 2 times 1 And that gives us our 2 1s like that. And so this 6x plus 2 represents the area. Yeah, that's definitely the area. And this is the area of this multiplication. And I can do this algebraically by distributing that 2, that common side length of 2, to the 3x length, this length here, and the common side length of 1, which is this length here. Okay, and that allows me to justify this distribution, which gives me the correct area.